All right, we're going to run through each of the exercises in practice 1D. So for the think about it question number 1, we're thinking about the equation, the absolute value of x is equal to y. If x is a negative number, let's just pick a negative number and replace x with that number. What will happen to y? Well, y is equal to the absolute value of -3, and so y will be a positive number. And more specifically, the opposite of the x value. If x is 0, replace x with 0, then y will be equal to 0 as well. If x is a positive number, let's just pick any positive number here, then y is also a positive number. And in this case, it'll be equal to the value of x. Now we're going to switch it around. What if y is negative? If y is negative, then our equation will look like this. The absolute value of x is equal to -3. There is no number whose absolute value is equal to -3, so I'm just going to say can have no value. In other words, the equation does not have a solution. If y is 0, take the equation, replace y with 0, then x also has to be 0. The absolute value of what number is equal to 0? The only answer to that is 0. And then if y is a positive number, so let's take our equation and replace the y with a positive number, then x can be either positive or negative, because the absolute value of what number is equal to 3? Either +3 or -3. Notice the word use of the word or there, either positive or negative. And I'm just going to put parenthetically here, same as x, or its opposite. All right, so keeping in mind that, we're going to solve some equations that have absolute values in them. Keep in mind order of operations. If you replaced x with a value in number 7, you would, in checking that value, subtract 2 and then take the absolute value and see if that's equal to -3. So we need to undo absolute value first. So your next step will say what x minus 2 has to equal. However, we need to actually think about this. Before we do anything, we need to think about the absolute value of what number is equal to -3. Oh my gosh, there's no number whose absolute value is equal to -3. So we can actually stop right there and say this equation has no solution. If you have an absolute value that is said to be equal to a negative number, you may stop right there and say no solution. All right, same idea for number 8. If we were replacing x with a number, we would multiply by 2 and then subtract 5 and then finally take the absolute value and see if that's equal to -7. So I need to undo absolute value first. So 2x minus 5 can be -7. What's inside the absolute value can be -7. Or 2x minus 5 can be +7. That'll give us 2 equations to solve. And so we're going to add 5 first here and then divide by 2. And we get 2 valid solutions, which you can check in the equation if you wish. All right, let's take a look at number 9. If I were checking in number 9, I would subtract my n value from 3 first, and then take its absolute value, and then finally add 1, and see if that's equal to 9. Remember I said finally add 1? That's the first thing that needs to be undone. So the absolute value of 3 minus n is equal to 8. Be careful when you are subtracting your 1 from both sides. The absolute values are still there. So now we need to undo them. So 3 minus n can either be negative 8 or 3 minus n can be positive 8. What's inside of the absolute values can be either a negative number or a positive number to produce 8 as its absolute value. All right, now from here, a more basic equation. We'll subtract 3 from both sides and then divide by negative 1, or subtract 3 from both sides and divide by negative 1. And so we get two solutions, either negative 5 or 11. Either order on your solution set is fine. All right, number 10, very similar setup here, right? We're going to subtract 5, take the absolute value, add 7 if we are checking a solution. So if we're solving, we have to undo that add 7 first. When we undo the add 7, we get the absolute value of an expression is equal to a negative number. There is no such thing as an absolute value that gives you a result that's negative. So that means that this equation has no solution. In number 11, 8 minus the absolute value of y is equal to 3. You might want to turn this into negative 1 times the absolute value of y plus 8 is equal to 3. A little bit easier in terms of solving. I'm going to subtract my 8 first. And we have to be very careful here. Yes, we get an absolute value that's equal, or rather we get an expression that's equal to a negative number, but we still have to divide by negative 1 in order to isolate the absolute value. Then we get the absolute value of y is equal to 5, which yields y is equal to negative 5 or y is equal to positive 5. So this does actually have two solutions. In number 12, thinking about order of operations, I would add 2 if checking a value of u, then take the absolute value, then add 3 and see if that gives us a result of 3. So the add 3 has to go away first. Subtract 3 from both sides. Now the absolute value has to go away. If the absolute value of a number is equal to 0, then that number inside has to be 0. There's only one number that has an absolute value of 0. Finally, subtract 2 from both sides, and we get one single solution, negative 2. You can write it that way, or you can write it as a solution set if you wish, with only one member. All right, let's take a look at number 13. By now, you've realized we need to take care of any operations that are outside of the absolute value first, so we'll divide through by negative 3. The absolute value of w plus 1 is equal to 5. Now undo the absolute value. That means w plus 1 must either equal negative 5 or w plus 1 must equal positive 5. Subtracting 1. And we get two solutions to this absolute value equation. For number 14, I would suggest that you undo the absolute value before you think about clearing fractions. Multiplying inside of an absolute value is a tricky thing. We can do it as long as the number is positive, but if the number is negative, we don't want to distribute inside of an absolute value. So it's best just not to mess with that. So I'm going to undo the absolute value first. If the absolute value of some expression is equal to 2, that expression can be negative 2, or that expression can be positive 2. Now let's multiply through by 6. That'll clear the fraction. Don't forget to distribute to both terms. And don't forget to distribute to the other side of the equation. That'll give us, subtracting 6 from both sides, x is negative 18. Or multiply through by 6 on our second equation, and we get x plus 6 is equal to 12, and x is 6, which gives us a solution set that contains the numbers negative 18 and 6. Remember, your solution set should have curly brackets. Parentheses are reserved for ordered pairs, which are points on a graph. All right, number 15. If you wish, you may rearrange this so we have 2 times the absolute value plus 5 is equal to 21. That's a little bit easier to look at. Subtract the 5 first. Divide by 2. Now that that absolute value is equal to a number, or the absolute value is by itself on one side, then think about the absolute value of what is equal to 8. The thing inside can either be -8 or the thing inside can be +8. Adding 1, we get a solution set with the two numbers -7, +9 as solutions to this equation. Remember, these are checkable. Number 16, I would suggest a similar rearrangement. -2 times the absolute value of y minus 5 plus 3 is equal to 1. Don't be tempted to distribute that -2. We may not distribute multiplication into an absolute value, even though the absolute value functions kind of like a parentheses. It is a grouping symbol, but it has additional responsibilities, and so we can't treat it the same as we treat a parentheses. All right, so I'm going to undo the +3 first by subtracting 3, and now divide by -2, and that'll give us the absolute value of y minus 5 is equal to 1. Now undo the absolute value, y minus 5 is -1, or y minus 5 can be +1. If the absolute value of a number is equal to 1, the two possibilities for the number are -1 and +1. Adding 5, our solution set contains the two numbers 4 and 6. For number 17, we're going to undo the -6 first, the outermost or last operation to be done if we were checking a solution. So adding 6 to both sides, dividing by 3. Now we have the absolute value of something equals a positive number. So the absolute value of 10 is 10, and the absolute value of -10 is also 10. So 5m minus 7 may be equal to -10, or 5m minus 7 may be equal to +10. Adding 7 and dividing by 5. Adding 7 and dividing by 5. It's okay, not every solution set will yield integer values. All right, and last one of this type. Again, I suggest you rearrange this. -2 times c plus 3 plus 1 is equal to 9. We're going to subtract the 1 and then divide through by -2. Now we get the absolute value of something is equal to a negative number. You may know immediately here that there is no solution to this equation because there is no expression that you can take the absolute value of and get a result that is a negative number. All right, last couple here. These are absolute values on both sides, and if the absolute value of one expression equals another expression, then those two expressions might be equal. They might be the same number, or the two expressions might be opposite. Now what I did is, notice I multiplied both of the terms by -1 on the right side of the equation. The equation on the left, we can subtract off 3x from both sides. -2x plus 3 is equal to -7. Subtract 3, and that gives us -2x is equal to -10. So x is 5. That's one solution. Or adding 3x to both sides, 4x plus 3 is equal to 7. Subtracting 3, 4x is equal to 4, x is equal to 1. We have two valid solutions. Remember, those are checkable. And last one of this type. If two expressions have equal absolute values, that means the two expressions can be equal to one another, or the two expressions can be opposites, and the opposite of x minus 7 is negative x plus 7. All right, let's solve the equation on the left. Subtracting x gives us negative 5 equals negative 7. This equation has no solution, but that doesn't mean the entire equation has no solution, just this part. All right, let's solve the one on the right. So adding x, 2x minus 5 is equal to 7. And then adding 5, 2x is equal to 12. That gives us a solution of x equals 6. So this equation has just one member in its solution set. There's only one solution where we might be expecting two. All right, in 21 through 24, we're just going to check some numbers here and see if they are solutions to each inequality. So the absolute value of x is less than 3. Let's just go through and check some numbers here. Now remember, this integer set, see those dot dot dots at both ends? Those are called ellipses, and those indicate kind of like you would use the word etc. if you in the English language, right? It means that list just keeps going and going and going. We can't possibly list it all, so we kind of say etc. instead. So I'm just going to pick a number that we don't see, but is in that set, and I'm going to see if that works. Is that true? That's not true. The absolute value of negative 4 is 4. That's not less than 3, so we can cross that number off. Let's change it. What if we used the number negative 3? Well, that would give us 3 is less than 3. We can cross that one off. What if we used the number negative 2? That would give us 2 is less than 3. Hey, that's a solution. If we use the number negative 1, that would give us 1 is less than 3. That's also a solution. If we used the number 0, that would give us 0 is less than 3. Hey, that's a solution. In fact, 1 and 2 are also solutions. 3 is not going to give us a solution, right? If we replace x with 3, we get 3 is less than 3. That's not true. If we replace x with 4, again, we're going to get something that's not a solution. So I think we've found all of our solutions. They're just negative 2, negative 1, 0, 1, and 2. Those are the only solutions to the absolute value of x is less than 3. All right, let's check out the next one. The absolute value of n is greater than 2. All right, let's try some values here. Let's try negative 4. The absolute value of negative 4 is 4. 4 is greater than 2. That one works. What if we changed it to negative 3? 3 is greater than 2. That one works. So I'm going to circle the negative 3. And then let's change it again. Let's change it to negative 2. That gives us 2 is greater than 2. That's not good. What if we changed it to negative 1? That'd give us 1 is greater than 2. That's not true either. What about 0? 0 is greater than 2? Nope. 1? 1 is greater than 2? Nope. 2? 2 is greater than 2? Nope. Don't give up yet. If we change it to n to 3, 3 is greater than 2. Oh, that one works. What if we kept going? 4? 4 is greater than 2. That works. So it seems like the ones that work are from the end here, -5, -4, -3, not -2, -1, 0, 1, and 2, 3, 4, 5, etc. Okay, so there's kind of a pattern to that one. Just the ones on the sort of the outsides there. All right, let's check out number 23. And this time we're using the variable k, but it doesn't really matter. Same thing. Let's check some numbers here. Let's check -3. That would give us 3 is greater than or equal to -1. That's true. If we replace x with, k with -2, that gives us 2 is greater than -1. Cool, that one works too. If we replace k with -1, 1 is greater than -1. That's a true statement. Replace k with 0, 0 is greater than -1. Also true. Replace k with 1, 1 is greater than 1. Hey, these seem like they're all true. If I take the absolute value of a number, I'm going to get a positive result or possibly 0. And that number is always going to be bigger than -1, isn't it? So the answer to this one is basically all of those integers up there. They are all solutions to this inequality. All right, and last one. Get rid of my markings there, and let's test some things out. The absolute value of w is less than or equal to 0. Let's put -3 in. Is 3 less than or equal to 0? Nope. Let's replace w with -2. Is 2 less than or is equal to 0? Nope. Let's replace w with -1. Is 1 less than or equal to 0? Nope. Let's replace w with 0. Is 0 less than or equal to 0? Oh, well, yeah, it is, right? It's equal to, so that counts. And now let's replace w with 1. And again, we get numbers that are not less than or equal to 0. So I think 1, 2, 3, we can probably eliminate those. So it looks like there's only one value that works in this inequality, and that's the number 0. So we're actually kind of testing those values, and that is something that is a legitimate strategy to kind of get the idea of what you're doing. All right, last one is a standardized test question. And it states that a and b are solutions to this equation above. So it kind of hints they want you to find those solutions. So if the absolute value of 3x minus 6 is equal to 3, then 3x minus 6 can equal -3, or 3x minus 6 can equal +3. Adding 6 and dividing by 3, we get one solution of 1. And adding 6 and dividing by 3, we get another solution of 3. Now you might ask, hey, if those are the solutions, how do we know which one's A and which one's B? Well, let's see if it matters. Let's imagine that A is equal to 1 and B is equal to 3. Then the absolute value of A minus B would be the absolute value of 1 minus 3, which is the absolute value of -2, which is 2. But now, let's see what would happen if we make A 3 and B 1. Then the absolute value of A minus B would be the absolute value of 3 minus 1, which is the absolute value of 2, which is also 2. Turns out it doesn't matter which way you did this. A and B, we get the same answer. So final answer here, the absolute value of A minus B is 2. And that's it.